July 24, 1943. 120 miles west of Truk Lagoon. The periscope lens fogged slightly as Lieutenant Commander Lawrence Randall Daspit watched something that would shatter every assumption the United States Navy held about its primary weapon. Through the crosshairs, a 19,262-ton Japanese tanker sat dead in the water, crippled, defenseless, the largest target a submarine commander could hope to find. He had already hit it twice with torpedoes, two perfect explosions that disabled the ship's engines. Now came the textbook finish. The kill shot from point-blank range at a 90-degree angle. The geometry of submarine warfare perfection. What Daspit witnessed over the next hour would expose the greatest weapons scandal in American military history. A systematic failure so profound that it had been sending American submariners into combat with weapons that worked only 20% of the time. For 18 months, the United States Navy had been fighting the Pacific War with defective torpedoes. Submariners had been dying for nothing. Japanese convoys had been sailing unmolested. And the men responsible for fixing the problem had been blaming the victims. But on this day, one submarine commander would document evidence so damning that even the most powerful bureaucracy in the Navy could no longer deny the truth. The Mark 14 torpedo, America's most advanced weapon, was fundamentally broken. And it would take one man's impossible investigation, conducted against direct orders and at the risk of his career, to fix it. The cost of bureaucratic failure was being measured not in dollars, but in ships unsunk, sailors dead, and a war prolonged. The mathematics of victory were being rewritten in the waters west of Truk, and Lawrence Daspit was about to provide the evidence that would change everything. The nightmare had begun on December 8, 1941. Just hours after Pearl Harbor, Admiral Chester Nimitz had ordered unrestricted submarine warfare against all Japanese shipping. The United States submarine force went to war with supreme confidence. They possessed what they believed was the finest torpedo in the world, the Mark 14, designed at the Naval Torpedo Station in Newport, Rhode Island. It was a marvel of engineering. 20 feet 6 inches long, 21 inches in diameter, 3,000 pounds of precision machinery, capable of traveling 4,500 yards at 46 knots, or 9,000 yards at a slower speed of 31 knots. Each torpedo cost $10,000 in 1931 money, the equivalent of $180,000 today, more than 15 new automobiles. This was not a weapon to be wasted on testing. The Mark 14 carried a warhead containing 643 pounds of high-explosive torpex. But its true innovation lay in the Mark 6 magnetic influence exploder. Developed in absolute secrecy starting in 1922, the magnetic exploder was designed to detonate beneath a ship's keel, where there was no armor. The explosion would create a massive gas bubble that would literally break the ship's back. A single hit could sink a battleship, or so the theory went. The Navy had been so confident in the weapon that it conducted exactly 2 live fire tests, both on May 26, 1926. The first test failed completely. The torpedo passed under the target without exploding. The second test succeeded, deliberately destroying the decommissioned submarine USS L-8, which had been stricken from the Navy list specifically for this purpose. Then for 17 years, until December 1941, not a single additional live fire test was conducted. The reason was simple. Torpedoes were expensive. The Great Depression had strangled military budgets. Congress had slashed Navy funding throughout the 1930s. The naval torpedo, stationed at Newport, employed 3,000 workers running 3 shifts around the clock and still only produced 1.5 torpedoes per day. Production was so slow that torpedo shortages began before the war even started. By January 1938, unfilled torpedo orders amounted to $29 million. There was simply no money and no supply for destructive testing. So the Navy tested the Mark 14 using lightweight practice warheads that allowed the torpedoes to float when they ran out of fuel. The practice warheads were recovered, examined, and pronounced perfect. The magnetic exploder was tested in laboratory tanks of still water. The results were flawless. The Bureau of Ordnance declared the Mark 14 ready for war. But weapons designed in laboratory conditions and tested with dummy warheads do not always work in combat. On December 24, 1941, just 16 days into the war, Commander Tyrrell Dwight Jacobs in USS Sargo fired 8 torpedoes at 2 Japanese merchant ships. 0 hits, 0 explosions. Jacobs was certain his fire control solution was perfect. He had pursued one target for 57 minutes, ensuring his calculations matched perfectly before firing, but 8 torpedoes produced nothing. A week earlier, on December 14th, USS Seawolf had reported that torpedoes were running deeper than their depth settings. The commanding officer estimated the torpedoes passed 10 to 15 feet below the targets, too deep for the magnetic exploder to detect the ship's magnetic field, too deep for contact hits. The reports multiplied. USS Sargo reported the first premature explosion just 1 week after Pearl Harbor. A torpedo had exploded halfway to its target. USS Skipjack, USS Stingray, USS Sturgeon. From every patrol area, submarine commanders sent the same message. The torpedoes were not working. They ran too deep. They exploded prematurely. They failed to explode at all. Or most terrifyingly, they circled back toward their own submarines. By June 1942, American submarines had fired over 800 torpedoes in combat. 80% had failed. 8 out of every 10 torpedoes fired at the enemy either missed, malfunctioned, or failed to detonate. The mathematics were devastating. American submarines should have been destroying the Japanese merchant marine. Instead, Japanese convoys sailed largely unmolested, while American submariners risked their lives with weapons that didn't work. The submarine commanders knew something was fundamentally wrong. They sent detailed reports to their superiors. They documented every attack, every malfunction, every failure. They requested investigations. They demanded tests. The response from the Bureau of Ordnance was consistent and insulting. The problem was not the torpedoes. The problem was the submarine commanders. They were making poor approaches. They were miscalculating firing solutions. They were failing to maintain the weapons properly. The Bureau of Ordnance had designed the Mark 14. The Naval Torpedo Station had built it. 2 decades of engineering had gone into its development. The fault could not possibly lie with the weapon. The fault must lie with the men using it. At Pearl Harbor, Rear Admiral Thomas Withers, Commander Submarines Pacific, consistently sided with the Bureau of Ordnance. When his submarine commanders complained about torpedo failures, Withers blamed their lack of initiative. The expensive torpedoes were in short supply. They could not be wasted on field testing. Board had declared the weapons sound. That was the end of the discussion. But one man was listening to the submarine commanders, Rear Admiral Charles Lockwood. Born in Midland, Virginia, on May 6, 1890, Lockwood had graduated from the United States Naval Academy in 1912. His submarine career began in September 1914 when he reported to the tender USS Mohican for submarine training. By December 1, 1914, he commanded USS A-2, the Navy's second submarine. Lockwood had spent nearly 3 decades in submarines. He understood the men who commanded them. He knew they were reporting genuine problems. When submarine commanders with years of experience all reported the same failures, Lockwood listened. In May 1942, Lockwood became Commander Submarines Southwest Pacific Area, based in Fremantle, Australia. He immediately found himself dealing with the Mark 14 controversy. His submarine commanders were reporting catastrophic failure rates. Japanese ships were escaping. American submarines were accomplishing almost nothing despite taking enormous risks. Lockwood knew BUORD would never authorize official testing. The torpedoes were too expensive. The supply was too limited. But Lockwood also knew that sending men into combat with defective weapons was infinitely more expensive than testing. In June 1942, Lockwood did something unprecedented. He ordered unauthorized tests of the Mark 14 torpedo against Bureau of Ordnance regulations without permission. At risk to his career, he was going to find out if the torpedoes really ran deep. Captain James Fife, Lockwood's chief of staff, devised an ingeniously simple test. They would fire torpedoes through fishing nets suspended at known depths in Frenchman Bay near Albany, Australia. On June 20th, 1942, USS Skipjack fired a single torpedo with an exercise warhead from 850 yards. The torpedo was set for a depth of 10 feet. It should have pierced the net at 10 feet. Instead, it ripped through the net at 25 feet, 15 feet deeper than the setting. The next day, James Fife supervised 2 more test shots. Both torpedoes ran 11 feet deeper than set. The evidence was conclusive. The Mark 14 ran dangerously deep. Lockwood immediately reported his findings to the Bureau of Ordnance. The response was swift and dismissive. No reliable conclusions could be drawn from Lockwood's tests. The fishing net method was not scientifically valid. The submarine commanders must have trimmed the torpedoes improperly. Lockwood repeated the tests. 3 torpedoes set at 10 feet, cut the net at 21 feet, 11 feet deeper than the setting. Still, the Bureau of Ordnance refused to accept the evidence. Their tests at Newport showed no depth problems. The fault must lie with the submarine force. Admiral Ernest Joseph King, Chief of Naval Operations, had heard enough. King was not a man to tolerate bureaucratic nonsense. He ordered the Bureau of Ordnance to conduct their own tests, immediately. In July 1942, the Bureau finally tested the Mark 14 at Newport. In August 1942, more than 8 months into the war, the Bureau of Ordnance officially admitted that the Mark 14 torpedo ran 11 feet deeper than set. The cause was a nested series of design flaws. During development, the torpedoes had been tested with lightweight exercise warheads. When loaded with heavy combat warheads containing 680 pounds of explosive, the torpedoes naturally ran deeper. But that was only part of the problem. The depth control mechanism used a pressure sensor to measure water depth. During testing, this sensor had been placed in the torpedo's conical tail section. At 46 knots, water flowing past the conical shape created a low-pressure area. The pressure sensor incorrectly interpreted this as shallow depth and directed the torpedo to dive deeper. The faster the torpedo travelled, the deeper it ran. This problem could have been discovered with a single test using a full warhead, but that test was never conducted because torpedoes were too expensive to destroy. By August 1942, the depth problem was identified. The Bureau of Ordnance issued new instructions for calibrating the depth mechanism. Submarine, commanders began setting their torpedoes to run at 0 depth to compensate for the 11-foot error. The Navy believed the torpedo problem was solved. It was not. With the torpedoes now running at the correct depth, a new problem emerged: premature explosions. Torpedoes were exploding before reaching their targets. The explosions occurred hundreds of yards short of Japanese ships. Submarine commanders watched through their periscopes as torpedoes detonated harmlessly in open water. The magnetic exploder was firing too early. On April 9, 1943, Lieutenant Commander John A. Scott in USS Tunney found himself in a perfect attack position. 3 Japanese aircraft carriers, Hyo, Junyo, and Taiyo. Range only 880 yards. Point-blank range for a submarine attack. Scott fired all 10 torpedo tubes. He heard 7 explosions, but none of the carriers slowed. None showed damage. All 3 continued at full speed. Intelligence analysis later revealed that all 7 torpedoes had exploded prematurely. The magnetic exploder had triggered too early. Not one torpedo had reached its target. On April 10, 1943, USS Pompano attacked Japanese aircraft carrier Shokaku with 6 torpedoes. At least 3 exploded prematurely. The carrier was undamaged. On June 10, 1943, USS Trigger fired 6 torpedoes at aircraft carrier Hyo from 1,200 yards. 1 missed cleanly, 1 exploded prematurely, 1 was a dud. 2 hit and caused minor damage. The carrier survived and limped home. The pattern was undeniable. The magnetic exploder was unreliable. On April 27, 1943, The Bureau of Ordnance finally admitted the Mark VI exploder was susceptible to premature explosions at shallow depths. The Bureau recommended disconnecting the magnetic feature in favor of contact shots, but even this admission came with conditions. The Bureau wanted to increase the arming distance from 450 yards to 700 yards. They wanted submarine commanders to fire only under specific conditions that would minimize premature explosions. Admiral King rejected the increased arming distance. 700 yards was unacceptable. Submarines needed to get close to their targets. King agreed with Lockwood. The magnetic exploder should be disabled. On June 24, 1943, Admiral Chester Nimitz ordered all submarines in the Pacific Fleet to deactivate the magnetic influence exploder. Use only the contact exploder. 18 months into the war, the Navy finally admitted that the magnetic exploder was a failure. But the Bureau of Ordnance's problems were designed into the weapon from the beginning. The magnetic exploder was so secret that even submarine commanders were forbidden to examine it. Bureau of Ordnance regulations required torpedo shops to apply dabs of paint to the screws holding the exploder mechanism. Any tampering would mar the paint. Submarine commanders were literally prohibited from examining the weapon they were risking their lives to use. But submariners are an independent and resourceful group. Torpedomen in the submarine bases would ask the paint shop what color paint was being used. If told blue, they would acquire small cans of matching blue paint. They would open the exploder mechanisms, make their own modifications, then carefully repaint the screw heads. When torpedoes were returned to the official shops, there was no evidence of tampering. By mid-1943, submarine commanders across the Pacific were quietly disabling the magnetic exploder on their own. They were doctoring their patrol reports, overstating the size of enemy ships to justify using more torpedoes. They were lying to their superiors because the alternative was dying for nothing. Only one area commander insisted that his submarines continue using the magnetic exploder, Rear Admiral Ralph Waldo Christie. Commander Submarines Southwest Pacific. Area. Christie had been the officer in charge of developing the Mark VI magnetic exploder in the 1920s and 1930s. He had spent years perfecting the device. He had staked his reputation on its success. Despite mounting evidence of failure, Christie refused to believe his creation was flawed. He ordered his submarines to continue using the magnetic exploder. His submarine commanders were furious. They watched their torpedoes explode prematurely or fail completely while submarines under Lockwood's command, operating with the magnetic feature disabled, were finally achieving success. Christie's boats continued to suffer catastrophic failure rates while Lockwood's boats began sinking Japanese ships. It would take a direct order from Admiral Thomas Kinkaid, Commander Allied Naval Forces Southwest Pacific Area, in November 1943, to finally force Christie to disable the magnetic exploder in his area. But even with the depth problem fixed and the magnetic exploder disabled, torpedoes were still failing. Now submarine commanders reported a third problem: duds. Torpedoes that hit Japanese ships and failed to explode. On July 24, 1943, Lieutenant Commander Lawrence Daspit in USS Tinosa encountered the target every submarine commander dreamed of finding: a 19,262-ton tanker. Alone, unescorted. Codebreakers had provided advance warning of the ship's route. Tinosa was perfectly positioned. At 0555, Daspit spotted Tonanmaru No. 3 heading directly toward him. At 0928, Daspit fired 4 torpedoes from 4,000 yards. His sonarman heard 4 distinct thumps as the torpedoes struck the hull, but only 2 exploded. The explosions hit the tanker's engine room. The ship stopped dead in the water, listing to port. Daspit moved in for the kill. With the target sitting motionless, Daspit had time to set up the perfect attack. He positioned Tinosa at 875 yards, directly abeam of the tanker, a 90-degree angle, the ideal firing position that every submarine commander trained for, the geometry that should guarantee success. At 0930, Daspit fired torpedo No. 5, The torpedo ran straight and true. The crew watched its wake cut through the water like a deadly white finger reaching toward the target. The torpedo struck the hull. There was a dull thud, no explosion. Daspit could not believe what he had witnessed. He fired torpedo number 6. Hit. No explosion. Torpedo number 7. Hit. No explosion. Torpedo number 8. Hit. No explosion. Daspit called his torpedo officer into the conning tower. They examined the remaining torpedoes in the tubes. Everything appeared perfect. The torpedoes were properly maintained. The depth settings were correct. The contact exploders were armed. There was no mechanical explanation for the failures. Daspit fired torpedo number 9. Hit. No explosion. Torpedo number 10. Hit. No explosion. Torpedo number 11. Hit. No explosion. Daspit wrote in his patrol report, "This torpedo hit well aft on the port side, made a splash at the side of the ship, and was then observed to have taken a right turn and to jump clear of the water about 100 feet from the stern of the tanker. I find it hard to convince myself that I saw this." By this point, a Japanese destroyer had arrived and begun depth charging. Daspit had to leave. But before diving deep to evade the destroyer, he fired his remaining 4 torpedoes. Torpedo number 12. Hit. No explosion. Torpedo number 13. Hit. No explosion. Torpedo number 14. Hit. No explosion. Torpedo number 15. Hit. No explosion. 15 torpedoes fired. 11 confirmed hits from textbook range and angle. Only 2 explosions. Daspit had 1 torpedo remaining. He made a decision that would change naval history. He would save that torpedo and bring it back to Pearl Harbor for examination. He would not waste it on a target that torpedoes apparently could not sink. Daspit set course for Pearl Harbor, writing in his log what no submarine commander ever wanted to record. He was returning with an empty bag. USS Tinosa arrived at Pearl Harbor on August 4, 1943. Daspit went directly to Submarine Force Headquarters. Rear Admiral Charles Lockwood, who had replaced Robert English as Commander Submarines Pacific in February 1943 following English's death in a plane crash on January 21, met him at the door. Lockwood had been expecting an angry tirade. He later wrote, "I expected a torrent of cuss words, damning me, the Bureau of Ordnance, the Newport torpedo station and the base torpedo shop. I could not have blamed him. 19,000-ton tankers do not grow on trees. I think Dan was so furious as to be practically speechless." But Daspit did not explode. He was beyond anger. He simply described what had happened. 15 torpedoes, 11 confirmed hits, 2 explosions, a sitting target that sailed away because American torpedoes did not work. The single torpedo Tinosa had brought back was immediately taken to the submarine base torpedo shop. Technicians examined it thoroughly. They found nothing wrong. The torpedo was in perfect working order. According to every test, it should have exploded on impact. Lockwood knew he could not wait for Buord to act. They had denied the depth problem for months. They had denied the magnetic exploder problem for over a year. They would deny the dud problem until presented with evidence so overwhelming that denial became impossible. Lockwood decided to conduct his own investigation. Again without authorization, again against regulations, again at risk to his career. He ordered his gunnery and torpedo officer, Commander Art Taylor, to organize live fire tests. They would fire actual combat torpedoes with full warheads under conditions that simulated real attacks. Lieutenant Commander Swede Mommsen joined the investigation. Mommsen was already legendary in the submarine force. In 1939, he had led the rescue of 33 men from the sunken submarine USS Squalus. He had invented the Mommsen lung, a breathing device that saved countless lives. He understood mechanical systems, he understood testing, and he understood that the Mark 14 was killing American submariners. Taylor and Mommsen scoured charts of Hawaiian waters looking for the perfect test location. They needed sheer vertical cliffs that dropped straight into deep water with a sandy bottom where torpedoes could be recovered. They found the perfect spot on the coast of Kahoolawe, a small, uninhabited island southwest of Maui. On August 31st, 1943, USS Muskellunge fired 3 torpedoes with full warheads into the cliffs of Kahoolawe. The first 2 torpedoes exploded, the third did not. Mommsen personally dove into the water to examine the failed torpedo. It was broken in 2 pieces with the warhead split open. The warhead had not detonated. With extreme care, the crew hoisted the unexploded torpedo onto a barge and transported it to Pearl Harbor. After disconnecting the warhead, Mommsen and his technicians disassembled the exploder mechanism. What they found was shocking. The firing pin had been released from its restraint, but it had not travelled far enough along its guide rails to strike the primer cap with sufficient force to detonate the explosive. The impact of hitting the cliff at 46 knots had crushed the delicate mechanism. The faster and harder the torpedo hit, the more likely the firing pin would jam without triggering the explosion. A perfect 90-degree hit, the ideal attack angle that submarine commanders trained for, was the most likely to produce a dud. But Mommsen could not test his theory by firing more expensive warheads into cliffs. Lockwood approved a different approach. Art Taylor supervised the construction of a test rig. They acquired a crane from the Pearl Harbor shipyard. They filled dummy warheads with sand to match the weight of full explosives. Then they dropped the warheads from a height of 90 feet onto a steel plate positioned at various angles. 90 feet was carefully calculated. A warhead dropped from that height would strike the plate at the same velocity as a torpedo, traveling at 46 knots. The results were devastating. When warheads struck the plate at 90 degrees, the perfect perpendicular hit, 70% failed to detonate, 7 out of 10 duds. When warheads struck at 45 degrees, a glancing blow, only 50% failed. The oblique hits were twice as reliable as the perfect hits. The problem was obvious. The Mark VI exploder's firing pin mechanism was too delicate. It had been designed for slower torpedoes. The Mark III exploder used in World War I torpedoes had suffered from the same problem. Impact forces would drive the firing pin sideways in its guides, jamming it before it could strike the primer. The solution had been to install a stronger spring. But when the Mark VI exploder was developed in the 1920s, the designers ignored the lessons learned from the Mark III. They created a mechanism that was even more delicate. The faster Mark XIV, travelling at 46 knots instead of 30, generated impact forces that the firing pin mechanism could not withstand. Every submarine commander had been trained that a 90-degree shot was the ideal attack, but the 90-degree shot was the most likely to produce a dud. The Navy had been teaching submariners to use the one attack angle that was most likely to fail. Lockwood immediately sent a message to all submarines in his command. Do not fire at 90-degree angles. Fire at oblique angles, 45 degrees or less. The order baffled submarine commanders. It contradicted everything they had been taught. It made attacks more difficult, but it cut the dud rate in half. The message also served another purpose. It proved to the Bureau of Ordnance that the problem was real. Submarine commanders were not incompetent. The torpedoes were defective. Lockwood knew the oblique shot order was only a temporary solution. The firing pin mechanism had to be redesigned. But the Bureau of Ordnance controlled all torpedo modifications, and the Bureau was not interested in admitting another failure. So Lockwood took matters into his own hands. He ordered the submarine tender USS Holland to begin manufacturing modified firing pins. The solution was elegant. The original Mark VI exploder used a heavy steel firing pin block. Under high impact forces, this heavy block's inertia would cause the firing pin to jam. Lieutenant E.A. Johnson, under Taylor's supervision, designed a lighter firing pin block machined from aluminum alloy. The aluminum came from an unlikely source. Propellers from Japanese aircraft shot down during the attack on Pearl Harbor. The irony was not lost on the submariners. They were fixing American torpedoes using metal from Japanese planes. Johnson also developed an electrical firing switch as an alternative to the mechanical firing pin. Both solutions worked. Both were relatively simple to manufacture. On September 30th, 1943, USS Barb departed Pearl Harbor on patrol with 20 torpedoes, all equipped with the modified aluminum firing pins manufactured aboard USS Holland. The results were immediate and dramatic. Barb's torpedoes worked. By mid-October, Holland had produced enough modified firing pins for all submarines departing on patrol. Nearly 2 years into the war, the United States Navy finally had a working torpedo. The transformation was immediate. In 1942, American submarines fired 1,442 torpedoes and achieved limited success. Post-war analysis by the Joint Army-Navy Assessment Committee revealed the actual results were 134 ships totaling 580,390 tons. The actual success rate was far lower than wartime estimates. In 1944, with working torpedoes, American submarines sank 492 ships, totaling 2,387,780 tons. In 1945, they sank 132 ships, totaling 469,872 tons. The lower 1945 numbers reflected target scarcity after the successful campaign had devastated Japan's merchant marine. The Mark 14 torpedo, once fixed, became one of the most effective weapons of the Pacific War. American submarines sank 1,300, 14 Japanese vessels, totaling 5.3 million tons. They destroyed 60% of Japan's merchant marine. They strangled Japan's supply lines. They sank 8 aircraft carriers, 1 battleship, and 11 cruisers. They accounted for 55% of all Japanese shipping losses. But this success came at a terrible cost. The submarine force suffered the highest casualty rate of any branch of the American military. 22% of submariners who went on patrol never returned. 52 submarines were lost with all hands. 3,505 officers and men died. Many of those deaths occurred in the first 2 years of the war when torpedoes did not work. How many submarines were lost because their torpedoes failed at critical moments? How many submariners died because they had to make multiple attacks on targets that should have been destroyed with the first salvo? How many Japanese ships escaped to sink American vessels because submarine torpedoes were duds? The questions haunted Lockwood for the rest of his life. In September 1943, after the torpedo problems were finally solved, Lockwood described it as V-Day in submarine warfare. From September 30th, 1943 onward, American submarines were truly effective weapons. But Lockwood never stopped thinking about what might have been. He later wrote, "Had the torpedoes been properly tested before the war, we would have entered combat with weapons that functioned. The war would have been shorter. Many lives would have been saved." Bureau never officially apologized. In their post-war analysis, the Bureau admitted that testing had been inadequate. They acknowledged that production planning had been faulty. They conceded that torpedoes were designed for meticulous, small-scale manufacture that could not be scaled up for war production. The Bureau's final report stated, "Even with the relatively meager funds available in time of peace, much of the work now being done after more than a year and a half of war could and should have been accomplished years ago. That the work was not accomplished during peace, or earlier during the war, or so far as the Bureau's records disclose that no one either at the Bureau or at Newport apparently questioned the inadequacy of the design without such tests, shows a lack of practical appreciation of the problems involved, which is incompatible with the Bureau's high standards and reflects discredit upon both the Bureau of Ordnance and the Naval Torpedo Station, Newport. The Chief of the Bureau therefore directs that as a matter of permanent policy, no service torpedo device ever be adopted as standard until it has been tested under conditions simulating as nearly as possible those which will be encountered in battle." It was an extraordinary admission, but it came too late for the submariners who had died with defective weapons. The torpedo scandal revealed fundamental flaws in how the Navy developed and tested weapons. Cost considerations had overridden operational effectiveness. Secrecy had prevented the people who used weapons from understanding how they worked. Bureaucratic pride had delayed fixes for problems that field commanders identified within weeks of the war starting. BUOD had spent 20 years developing a torpedo that did not work. They had refused to believe reports from the men who risked their lives using it. They had blamed submarine commanders for incompetence rather than admitting design flaws. And when the problems could no longer be denied, they fought every fix, every modification, every improvement. Charles Lockwood became the hero of the story not because he was a brilliant engineer. He was a hero because he listened to his submarine commanders. He trusted their expertise. He risked his career to conduct unauthorized tests. He bypassed bureaucratic channels when official channels failed. He took personal responsibility for fixing weapons that were not his responsibility to fix. And most importantly, he refused to send men into combat with weapons he knew were defective. Lockwood's unauthorized investigation at Frenchman Bay in June 1942 proved the depth problem. His unauthorized tests at Kahoolawe in August 1943 proved the dud problem. His unauthorized manufacturing operation aboard USS Holland in September 1943 provided the fix that finally gave American submariners working torpedoes. Every step violated regulations. Every decision risked court-martial. Every action challenged the authority of BUOD, one of the most powerful organizations in the Navy. But Lockwood understood something that the Bureau did not. The purpose of weapons is to work. The purpose of tests is to find failures. The purpose of leadership is to fix problems, not to deny them. By war's end, Lockwood had been promoted to Vice Admiral. He attended the surrender ceremony aboard USS Missouri on September 2, 1945. He stood among the senior Allied commanders who had defeated Japan. His submarine force had sunk more Japanese shipping than all other forces combined. The Mark 14 torpedo had become one of the most feared weapons in the Pacific. But the torpedo's success came from the courage of one man who refused to accept failure. The story of the Mark 14 torpedo scandal is ultimately a story about testing, or rather, the failure to test. In 1931, a new automobile cost $700. The Mark 14 torpedo cost $10,000. The Navy decided that torpedoes were too expensive to destroy in testing. So they tested using lightweight dummy warheads. They tested the magnetic exploder in laboratory tanks. They conducted exactly 2 live fire tests in 1926. Then they sent the weapon to war. The cost of not testing was measured in failed attacks, lost submarines, dead submariners, and a war prolonged. By 1944, the United States was producing 150 Mark 14 torpedoes per day. Total wartime production exceeded 60,000 torpedoes. At $10,000 each in 1930 dollars, that is $600 million, or $12 billion in today's money. How much would proper testing have cost? A few dozen torpedoes destroyed in realistic tests would have revealed the depth problem, the magnetic exploder problem, and the firing pin problem before the war began. The cost would have been perhaps $500,000 in 1930 money, less than the cost of a single submarine. Instead, the Navy fought the war for 2 years with defective weapons. Submarine commanders achieved roughly 20% success rates when they should have achieved 80% or better. Japanese merchant ships that should have been destroyed in 1942 continued operating until 1944. Every month those ships operated, they supplied Japanese forces. Every Japanese soldier who received supplies from those ships had the opportunity to kill American soldiers. Every Japanese aircraft that received fuel from those tankers had the opportunity to shoot down American pilots. The mathematics are sobering. If American torpedoes had worked properly from December 1941, the submarine force could have achieved in 1 year what it actually took 3 years to accomplish. Japan's merchant marine would have been destroyed by 1943 instead of 1945. The war might have ended years earlier. Tens of thousands of lives might have been saved. All for the cost of proper testing. 50 torpedoes destroyed in realistic tests in 1939. $500,000 that would have saved billions of dollars and immeasurable lives. But the Bureau of Ordnance decided that testing was too expensive. They were wrong. Not testing was far more expensive. Today, the torpedo scandal is studied at military academies as a cautionary tale. It teaches several critical lessons. First, systems must be tested under realistic conditions. Laboratory tests and dummy warheads do not reveal how weapons perform in combat. Second, the people who use weapons must be involved in testing and development. Submarine commanders understood torpedo problems within weeks of the war starting, but they were not consulted during development. Third, bureaucratic organizations must be willing to admit mistakes. BUORD spent 2 years denying problems that were obvious to everyone in the field. Fourth, secrecy can be counterproductive. The magnetic exploder was so secret that even submarine commanders were forbidden to examine it. This prevented the people who understood the weapon best from identifying its flaws. Fifth, leadership means listening, trusting expertise, and taking risks to fix problems. Lockwood demonstrated that real leadership means challenging authority when authority is wrong and refusing to send people into danger with equipment you know is defective. By September 1943, American submarines finally had working torpedoes. The transformation was immediate. Submarine commanders who had endured 2 years of failures finally had weapons they could trust. USS Tang, under Commander Richard O'Kane, achieved remarkable success. USS Barb, equipped with the modified firing pins from USS Holland, began a legendary combat record. American submarines patrolled the sea lanes around Japan, the Philippine Sea, the East China Sea, and the South China Sea. They destroyed tankers, freighters, troopships, and warships. Japan's war economy ground to a halt, as raw materials from the conquered territories could no longer reach the home islands. Oil from the Dutch East Indies, rubber from Malaya, food from Indochina, all had to travel by sea. And American submarines with working torpedoes controlled the seas. By 1945, Japan was strangled. Her industries had no raw materials. Her cities had no food. Her military had no fuel. American submarines had accomplished what strategic bombing and surface naval battles could not. They had destroyed Japan's ability to continue the war. And they had done it with a weapon that, when it finally worked, was devastating. The Mark 14 torpedo remained in service until 1980. It was upgraded, modified, and improved over the decades. But it never would have become the effective weapon it was without Charles Lockwood's impossible investigation. One admiral who refused to accept defective weapons, one investigation conducted against orders, one test that proved what everyone already knew: the torpedoes did not work. And one decision to fix them, regardless of regulations, regardless of bureaucracy, regardless of risk. Charles Lockwood died on June 6, 1967. He was 77 years old. He is buried at Golden Gate National Cemetery in San Bruno, California, alongside Admirals Chester Nimitz, Raymond Spruance, and Richmond Kelly Turner. All heroes of the Pacific War. All leaders who transformed defeat into victory. But Lockwood's greatest victory was not won in combat. It was won in the investigation, at Frenchman Bay, in the tests at Kahoolawe, in the manufacturing aboard USS Holland. It was won in conference rooms in Washington where he challenged BUORD. It was won in every patrol briefing where he listened to submarine commanders. It was won in every decision to trust his people over bureaucracy. His legacy is the lesson that leadership means having the courage to challenge authority when lives depend on it. It means conducting the impossible investigation that everyone says cannot be done. It means fixing the problems that everyone says do not exist. It means listening to your people when the bureaucracy does not. And it means refusing to send anyone into combat with weapons you know are broken. That was Charles Lockwood's impossible investigation. And that is how one admiral fixed America's broken torpedoes.